This is the ROS Developers Podcast, episode 66.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez from The Construct here today, and I would like to dedicate this episode to those ROS developers that want to build their own robot for doing ROS experiments, especially with deep learning. So all of you that you are not only doing software things and working on your computer, but you also actually want to apply to real robots, and you are building those robots that allow you to work with deep learning in the robot with ROS. So for all of you, this episode is dedicated to you. And today we are going to talk with a ROS developer that has built actually a ROS robot based on Nvidia Jetson Nano. And he has done this in order to do deep learning experiments with ROS robots. So we are going to talk with him in a few minutes. But before going into that, let me remind you about our ROS Online Academy. Yes, at The Construct, we have created an online academy called the Robot Ignite Academy. You probably already know about it. This academy contains a full path of lessons and courses clearly specified to make of you a ROS developer. So we start by teaching you about Linux and Python for robotics, and then we continue teaching you all the basic ROS concepts required to become a master of ROS. Then we conclude with a course that teaches you how to build your own robot and how to ROSify it, adding ROS control to it. I will put a link to that academy into the show notes below, okay? And apart from that, let me tell you that we have a special live course in Barcelona to teach you about how to program mobile robot manipulators. So this is a special live course. It's based on Barcelona city, and it's created in collaboration with Robotnik company. So we are going to deliver a 1-week live course in Barcelona to teach you how to make a mobile robot manipulator equipped with cameras, an arm, and wheels to move in a warehouse and do the typical pick and fill in the box tasks. So we are going to practice with the real robot RB Kairos from Robotnik, and then we are going to learn how to create a complete application, including the web interface for easy control of the robot by non-experts. That's amazing, okay? And then if you are interested to that, check our special website that is called masteringros.com. I will put a link also on the show notes below. But now it's time that we start with the subject of today. So it is my pleasure to introduce you again, Miguel Angel Rodriguez. Miguel Angel is the CTO of The Construct. Yes, it's the company I also work for. And there at The Construct, Miguel builds robots, develops ROS code, and he also creates online courses for learning ROS. He's also the host of the Morpheus Chair. You probably know Morpheus Chair is a YouTube show where he shows how to interact with ROS and real hardware. So here today to explain us about his latest robot built on top of Nvidia Jetson Nano. Welcome to the podcast, Miguel.
Thanks. It's a pleasure to be here.
Yes, it's a second time that you have.
It seems I didn't remember actually the last time I was here. So
it was some time ago.
Long time ago, yeah.
It was about the ROS jet. You were explaining
really?
about ROS jet.
Oh my God.
Yes,
long time.
Yes, yes, and now you are here because you have created this Nvidia Bot that you are calling. How do you call?
Ignis Bot. I know it's we like the name. Maybe we will change the future, but it's our nice and cozy name.
Okay.
Ignis Bot.
Yeah, that sounds great. Ignis Bot, Ignite Academy, Ignis Bot.
We are very intelligent people, I think.
Yeah. And what is the purpose of Ignis Bot?
So the purpose really is to give a very user-friendly experience for people that want to start using ROS, Nvidia Jetson Nano, and AI. So those three things. And basically, we want to give this nice experience to people so that they start coding and doing productive and useful things really fast. Because normally, when you get a robot, you spend a lot of time trying to make it work. So we are trying to make it affordable, but easy also.
Yes, and also powerful because it
Exactly.
contains a lot of powerful components. What are the sensors, actuators that the robot has?
So basically, we have sensors. We only have an RGB camera for that.
Uh-huh.
And then we have 2 servo motors that move the camera up and down, so the tilt movement. And then another one that moves the tail, because we wanted it to be like a robot dog. So something funny and juvenile, so very fun to work with.
Okay.
And also it has the classical DC motors for the wheels.
Okay, and then it has those 2 motors, additional motors, are for the tilt of the camera and
Exactly.
and another one for the tail. If I
For
haven't
the tail, for wagging the tail like a dog would.
Yeah. Okay. And what about the computer sensor? Computers, yes, power.
Yeah, so that's the main focus of this project, was using the Jetson Nano card made by Nvidia that's prepared exclusively really for AI applications that use CUDA.
Okay.
So basically that makes your AI applications really useful now because they go fast. It's not like using a CPU, which goes really slow.
Okay. So that would be the reason to use Nvidia Jetson Nano instead of, for example, Raspberry Pi.
Exactly, that's the best example, because in Morpheus Chair, for example, we made some other examples using Raspberry Pi. And it's a great board and it's really cheap. But the problem of that is that if you want to do something related to AI, it's not really prepared for that. So it just doesn't work.
Yeah.
So this Nvidia Jetson Nano, it's a game changer in that matter.
Yeah. Okay. Then in that Jetson Nano, you are installing a complete Ubuntu system, and then ROS.
Exactly. So
and then also on top, you can do even the deep learning thing on board.
Exactly, and it's really, I mean, the system that it's already installed. Really, we have a tutorial on how to install it. But basically, it has everything you need to do AI, and it's an Ubuntu, so really easy to use. So it's really user-friendly, so you can start doing things with AI quite fast.
Okay, but just to clarify for the audience, when you mean AI, you mean deep learning stuff?
Deep learning, because you can do AI with a CPU, normal CPU, but deep learning needs a lot of processing power. That having CPU, you would need like a 32 cores or something like that to have a similar performance.
Then we are making use of the GPUs inside there. Okay, and what about the development of the mechanical structure? How did you develop? Because it has a special shape of these robots. So I will put some pictures on the show notes so people can see it. And then how have you developed all these mechanical structure, including also the motors for wagging the tail or moving up and down the camera, etc.?
So as we thought about the project, so the first thing was we wanted to do something that was fun, that made use of deep learning, and then we thought, hey, we can do a robot that is like a dog, so that it tracks your face, people around, and it reacts to those people, those persons, and then it goes towards those persons wagging the tail. And not only that, but it's if you get close to the robot, then it wags the tail even harder. So based on that, then we thought, okay, for doing that, we need two things. One is that the camera can go up and down, basically to track a person going closer to it or moving forward or backwards and this kind of stuff.
To face the face.
Yeah, exactly. That always tracking your
face.
face. And then it has to give you a feedback that it's sensing your face, and the way of doing that is wagging the tail.
Okay.
So by tracking your face and wagging the tail proportionally to so you get closer, it wags the tail even harder. So doing that, it gives you a very good feedback that the robot is sensing you. So based on those two premises, then we said, hey, so we have to put 2 servos. So we have to modify the initial designs of the JetBot, which is the original project that Nvidia did for this, and then we built on top basically.
Okay, so, wait a second.
Yeah.
Can you explain us a little bit more about what this JetBot is and what is the role inside this Ignis Bot?
Sure. So basically, when Nvidia thought about this Nvidia Jetson Nano card, they knew that the people would need some kind of physical platform to use it. So they developed this very basic 2-wheeled structure robot, and it's open source, so you can see all the CAD files and everything.
We'll put a link also in the show notes.
And based on that, then you have like a basic 2-wheeled robot that you can do your basic deep learning things. But the problem is that it doesn't have the camera doesn't move, and there's no feedback, and there's no cover, so it's not useful to moving around. So that's basically what we wanted to do. We improved upon that.
Okay. So the JetBot is like the basis of the Ignis Bot, is in the core because it contains the Nvidia car and also the 2 wheels motors structure.
Yeah, like if we made for example, Linux has the basic kernel of Linux, which everyone uses. And then we have flavors. We have Fedora, we have Ubuntu. So we want to be like the Ubuntu version of JetBot.
Very good metaphor. And what about the mechanical structure that you put on top of it? How did you develop that?
So we developed it using an online platform for CAD design. So people that do CAD normally use SolidWorks or this kind of. So we used Onshape, which is online, totally online. The same thing that ROS Development Studio. It's the same philosophy. And
but for a different purpose.
Exactly. And then we designed all the pieces there, and we made the assembly of the robot there. So everyone can access it. It's public. So, and you can see how you have to assemble the robot.
Okay.
And based on there, we designed all the covers, the tail, the supports and mounts for the servos, this kind of stuff. So you can, as I said, we will put a link to the Onshape files.
The science. So people can, because this Ignis Bot is also open source, right?
Exactly. So what we want this project to be is a starting point for people to deep learning and Nvidia Jetson Nano, basically. And we wanted to be our official tiny robot for Robot Ignite Academy.
Okay.
So that people can have something physical that they can practice everything that they learn on the webpage.
Okay, and then if somebody that is listening now wants to get this robot, how can they get it? Do they have to buy from the Robot Ignite Academy, or they can build by themselves?
Both they can do. So we made a web page, and we'll link it in the description and the podcast. And basically, they can do two things. One, they can buy a box where you have everything you need to just assemble it, turn it on, and that's it. You have the robot running. You just have to assemble it.
Yeah. Okay. So it contains the software already installed.
Yeah, and the SD card with the
SD card, the 3D printed already material, everything. Okay.
So if you don't want to get, if you're not a person that likes to have a 3D printer and print your own stuff and this kind of stuff, I think this is the best option. But also you have the option of, we have a list of everything you need, all the instructions to do it, all the modifications you have to do to build your own. So you just have to go to Amazon or whatever and buy the parts and assemble it.
Print the 3D parts also by yourself, and then because it's open source.
Exactly. Everything we have done is open source. So basically, because we want to give something in return for Nvidia and all the community that.
Yeah. So because we have also gathered a lot from them.
Exactly. Yeah. So we wouldn't have built this robot without them. So.
Exactly. That's great. And then in which ROS version or distribution is it running?
It's melodic, just because basically Kinetic is dying, more or less. And melodic was also the best one, like working and so on. I thought that it was like the best of them.
Oh, okay. And then what about the Python version?
Yeah,
because deep learning, it's running on Python 3, most of the libraries.
Yeah.
So how do you manage? Did you manage to achieve to get it running in melodic that runs on Python 2?
Yeah, that's the thing. So when we have ROS with Python 3, which ROS 2 has and so on, and the newest versions, but now we have to work in a hybrid system. So we have to work with things that work in Python 2 and things that work in Python 3.
Yeah.
And as you said, in the deep learning, I understand that everyone is developing for the future, so Python 3.
Yeah.
And then what I built is basically we work with virtual environments in Python 3. So we execute things that we need Python 3, we execute it in that environment, and the other ones in the other one.
Okay, so you went through the virtual environment and then recompiling inside those virtual environments all the ROS packages required.
Yeah, we made a Catkin workspace for Python 3. So all the packages that you need to have in Python 3, we had to compile them for them.
Okay, so if we want to develop for that robot, then what would be the steps? So we want to develop, I'm talking about deep learning development of programs. So what would be the process?
So I think I highly recommend you that you do the course, just because it gives you...
Which course?
A course that we made for explaining every step that we did to have this go from nothing to basically having a Ignis Bot that makes people tracking and everything. Okay. So it gives you all the steps, assembly and configuration, simulations and everything. I highly recommend you that you do it. But basically the steps are, once you do it, you
build it.
You build your own robot, and then you download the simulation that we did also for it. And then you select a topic. There are many ideas in the Nvidia Jetson Nano forum.
Yeah, it's amazing.
So you can get very good ideas there. And then I highly recommend you that you try them first in simulation. And when it works, then try it on the real robot that you yourself built, so you know how it works. So it's much better to do it that way. And and then post it and share it, because we would be delighted to see what you do.
Yeah, that's right. Exactly. So listeners there. So if you are listening and then you would like to do some projects based on that robot and based on deep learning or any other type of learning for robotics, let us know, and we'll be happy to share with all the community also, and and make it spread around it. And then you have you said about these people follower tasks. So how does it work, and how have you made it work?
So I didn't develop the system that does what's called the post estimation. So the core of this project it's the Nvidia Jetson Nano, of course, but the software part is the TRT pose estimation system, which was developed by a person in the forum of Nvidia Jetson Nano forum. So that is the system that basically gets the image and gets the markings and all the pose of the person. And then what I did in the project was get that basic core and model, deep learning model that works and detects, and ROSified it. So publish everything in topics. And once we had those topics, then we can use all the ROS power to move the robot. So then I created another script that basically gets that and makes the robot behave as a dog. So wags the tail, moves the camera, moves the robot around with the wheels.
Based on the information
based on that information published in the topics that it's generated by this deep learning model.
Okay, so the post estimation package we would say that is the core of this people follower, and then this is running on deep learning models.
Exactly.
And so how did you train those deep learning models?
I didn't train them. Actually, when you execute it, you'll see that it downloads. So it downloads a model. It's pre-made.
Pre-made by the guy who even decided. It's interesting.
And that model, I suppose it wasn't made by him. So normally in deep learning, you get a model, like a pre-made model, and then you retrain it. Because training a model from scratch is really, really long. But what you do is adapt it to your system.
Okay. So in this case, I would say that this application, the people follower, is not training a robot, but using an already trained model. So it's an application that uses a trained model. And then it goes and then it goes. But then you also created another application that it's called the obstacle avoidance. So how does it work, that one?
So that one, we do train it. So it's really fun to train it because you can train it in simulation and you can train it in the real robot. And essentially what it does is it gets a pre-made model. And then what we do is in simulation or in the real robot, we get screen captures.
So it's screen captures from the camera of the robot itself?
Yeah, in simulation or in the real robot. And then we created a very simple GUI that what you do is you see an image and you say, hey, this is an obstacle or it's free.
Free space for moving.
Exactly. And then it basically puts the image in the correct folder. And once you have that, then you get all those images, you process them, you train the model, and then you make the predictions based on that model. That basically makes the robot navigate through an environment without crashing.
Nice. So that's a case, that's an example of using the Ignis Bot for doing supervised training.
Exactly.
Supervised learning,
And I can say that because we in the project that we've made, we execute it using GPUs and we use it also without GPUs.
Using just a CPU.
CPU. And the Nvidia Jetson Nano power, it's amazing. So it's like 10 times or more faster doing everything. The training and the predicting and all that stuff.
And the running the model, training.
So
amazing. And then on this course that you have created on the Robot Ignite Academy, that is published on the Robot Ignite Academy, then this you explain all those steps about how to do this training and how to deploy the model, how to use
Absolutely. We, as I said, we go from starting moving the robot. We also explain the obstacle avoidance, and we also explain the people tracker, how we ROSify the TRT. We also explain how to assemble the robot. There's how to set up the operating system, everything really.
Okay.
I mean, it's a course that after you do it, you have a good understanding of how to build this robot and how to have it in your home.
Okay, and how does it integrate with the simulation? Because you mentioned that you have already created a simulation of the robot. So even with the tail that wakes and so on, and the camera that tilts.
So in the course, you're using part of the course. So like 40% or 50%, it's in simulation, because what you do, you first train it in simulation. So you make mistakes and you don't break the robot, basically.
Exactly.
And so we have that simulation. And once you understand the principles and the things work, then you learn how to do it in the real robot, which sometimes you have to make some changes and sometimes you don't. Depends on.
Okay, interesting. And this simulation is also open source. So,
Absolutely.
So we are going to put also a link on the show notes.
Yeah, it has 2 environments, one for the collision avoidance.
Different ones.
Yeah, and one with people so that you can track them.
Okay. Okay, yeah, actually tomorrow, Tuesday, we are going to deliver a live class based on this simulation, and that we are going to use the people follower application.
Great.
So we are going to use this simulation.
Great.
So if you are there listening and you would like to attend, it's a free live class on our YouTube channel. Just tune to the Construct YouTube channel, and then at 6 CET, and then you will see that there is a live class that you can participate. Is not only for listening, but also for practicing. So you are going to practice at the same time with a teacher that is me. Also, actually,
it's a good teacher. It's a good teacher.
Well, we are working hard.
Trying,
we are working hard here. We are. What's the name? How can we say that in English? When you have multiple jobs and you are jumping from one to another.
Multi-employed or something?
Multi-employed. I don't know. You mean either.
You're a poor soul in life that has to work various jobs.
Yes, definitely yes. But we'll have coffee, so that's important.
Yeah, that's important.
And then one idea that I just got to my mind is that you mentioned before that after this course, you are going to build some other courses.
We are currently working on one, which is we talk about the topic of reinforcement learning using the collision avoidance principle. Then we use reinforcement learning to do unsupervised learning. So basically, that it knows which thing is an obstacle and
by itself.
By itself.
Using OpenAI with OpenAI.
With using OpenAI ROS. So it's a structure that we built on top OpenAI, but for ROS.
Yeah, and okay, so that's another one. But the idea that just popped into my mind is that we can use the simulation in order to create another course about how to do domain randomization. So in domain randomization, we train the models. We train the models in the simulation, and then we apply domain randomization during this training. So then later we can transfer the models directly into the real robot.
Yeah.
And then it doesn't need any retraining or I don't know. We can talk about that later.
We can talk about later.
Okay.
And then another thing and the next course that we'll prepare for this Ignis Bot is how to make it a ROS2 compatible robot.
Okay.
So both courses, I think they will be really useful for not only beginners, but anyone that it's interested in reinforcement learning and in ROS2.
Yeah, exactly. And then they can start practicing with a real robot.
Yeah, absolutely.
Okay, great. So then I think that this is all for today's episode. And anything that you would like to add, Miguel?
Well, please we would be delighted that people build their own versions of the robot and publish them in social media. It always touches our hearts that people with the things that we do, they do amazing things. So please do.
Okay, yes. So let us know. Thank you very much, Miguel Angel.
A pleasure being here.
And that is all for today, guys. So please remember to give us a review in iTunes. We have one now.
Wow.
The first iTunes review that we have. You can tell us whatever. If you like the podcast, that's great. If you don't like it, then tell us. Tell us, because we want to improve. But tell us something. Give us feedback. And tell us what you think about the podcast. But also you can suggest what you would like to have on the podcast. Okay, so that's all for today. Thank you very much for being here. See you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.